Welcome to Turn Right Machine Works. My name is Keith. Now today I'm going to show you how to make a margarita blender. Now this may seem to be a little extravagant or a little bit obese for a blender. This is going to be our tub here, and you know, back in my drinking days this wouldn't be enough, but this is for somebody else, so you know, I'm just doing what I'm asked to. Alright, so let's take the lid off our blender here, and you can see that this is a nice brute barrel made in USA. Actually made in Winchester, Virginia, USA. Alright, so we got, this is going to be the tub for our blender. Now what's going to drive our blender? Well, we're going to start out with an electric motor. And this is supplied by the customer, and this is also made in the USA. And this is a marathon motor. His choice is RPMs and everything else. And so we got this is gonna mount underneath the barrel itself. All right. So what we got to do is we got to be able to mount that. And you've already seen a couple of our cutouts as we've been going. And we have a series of plates. There's going to be two series of plates here that will sandwich on both sides. We have a Harwell, a very good quality bearing. I'm not sure if this is made in the USA or not, but it is nice, and it is a quality. And it says serving America's power transmission industry. So I'm taking it, this probably, you know, it's approved by Americans anyway. This is going to be a combination of sandwiching the bottom of the barrel. Alright, so we're going to be getting on to turning these in a minute. Now, we were only playing around. The customer brought us a couple blades here, and these got some nasty looking teeth on them, and these are also made in USA. And we kind of playing around with location, diameter, and angle and stuff, and we kind of came up with what we thought was going to work. And I went ahead and I cut up a sample just to play around with the bending, and we're basically going to have a blade that looks something like that. And we went ahead and we cut one out of stainless steel, and we practiced with our single line cutting here so that we can fold it, bend it on the right angles, and this is going to support those blades. Now the center of it is going to be the stainless steel hub here, and it's completely enclosed so we don't have any margarita juices leaking out onto the motor. And this will be welded up on here. We got to finish that bore. We're going to set that. We'll bend this all first and drill the holes in here to bolt our blades on right there. So that's kind of the plan. So let's get it going. All right, run the reamer through our hole there, and it looks like we're going to have a press fit on the hub there. That's going to be good. Alright, we'll go over to the Bridgeport now. Alright, we've drilled and countersunk our holes here to hold on these blades. And these are what's going to do the chomping on that margarita ice. And we're just carefully doing. All we have is 4 flute 1024 tap. I'm not really a fan of them. I like the 2 or 3 flute. More so the 2 fluters are really a strong tap. this plate thickness, probably a little overkill, but we didn't have anything, you know, it would drop down to like, oh, 14 gauge, something like that. And I think 3/16 would have been perfect. Alright, we'll do a test fit on the plate and threads, and then we can go bend the angles into our support here. There we go. I thought that was going to be a pretty good way to attach these here. Okay, we got our sample plate here, and we're kind of looking at it, and it had you know, we did practice on that. We were able to bend this somewhat in a vise, and this has a lot of slots in here. We wanted to increase the strength, but still let us bend that, and we have a bender or a brake that we can put in, excuse me, our hydraulic press, and we do pretty well with it. Now, we got to do a 15-degree bend out here and 10-degree bend on in here. And we want, the more important than anything else, is to make this and this equal, this and this equal. And then after we do our welding and everything, we'll be able to spin this, and then we'll check it with a pointer from side to side, and we're going to check and make sure that it's level and everything, so that this thing will spin and halfway be in a decent balance. And the reason why we're putting the bend and the shapes of this bend here is the blade position, and that's what this is all about. Now, I'm going to bend it in this bender, which is strong enough, more than strong enough to bend this thing, but I want to control it. Now, I don't have stops or anything else on here, but what I did is I set a dial indicator up here, and we're going to be able to come down in the down position X amount of distance, and we'll maintain that same exact location on the dial. We'll set it 0 or whatever, and then we're going to go to the other bend so that we can work them both at the same time and keep them exactly equal. Check the angle on here, which it's still just a little shy of our 15 degrees there, but we're going to go ahead and bend the other side to match. You always want to make sure you give enough travel for it to collapse a little bit also. Okay, now we're just going to press it down through here. Probably, I don't know, half an inch or so. It's about what we might have. Yeah, just a little bit more than a half an inch. Now we're going to be chucking on this in the lathe, and we'll spin it and we'll make sure we're all true. We can do some tacks and stuff like that. But this is going to be the start of our blade holder. Alright, we don't know yet what we're going to do on the leading edge here for a little sharpening, or what we're going to do. Okay, we finished the plate with the seal in it as far as the seal bore, and we put it over on the mill. We'll be doing the holes and a couple other things next on that. This plate here gets the register on the C-face adapter side of the motor, so they'll do the alignment, and then the other plate will be tied in with this, and then have the seal back, you know, sealing around the hub of the beater. Alright, I've got my two plates that are going to sandwich the pail bolted together, because I got the ones, this is the seal diameter I'm locating there so I can spin the OD. I got the bolt pattern, and two plates are bolted together. I want to skim the OD because I want to turn this around and do the register for the motor in the second plate. Now this is the second plate we cut out, and we have it relieved because in the bottom of the barrel we have some tangs that stick out, and it's got to fit in there. Now this is just a piece of brass in here that just happens to fit in here comfortably to let me do a friction drive right there between the plate and the chuck itself, and have enough swing in here so I clear the coverage. Now I'm going to use a D&MP tool bit here to skim that OD, and I'm just looking for round diameter so that I can repeat the bore of the seal, because we're going to do a register for the face and another seal bore on the motor side plate.